Okay guys, what we're going to look at now is the equation x squared equals c. Okay, now for the most part you guys should have a pretty good idea of how this might work. Okay, so if we have, for example, x squared equals 16, okay, and this is the same, this is an x squared equals c, where c is 16. Alright, so if you have this, you have to think of what number you would square to get 16. Okay, now to do this, what we do is we take the square root of both sides. Okay, so to get x squared into x, we have to take the square root. Okay, so on the left we will have x, and on the right we will have the square root of 16. Okay, and you guys should know that the square root of 16 is 4. Now, the reverse of this, okay, we know that 4 times 4 will give us 16, okay, so we know that that's the solution. Okay, if we put in 4 for x back in our original formula here, 4 times 4 is 16. However, we always get a second solution here. Okay, when we have x squared equals a positive number, we know that there are actually two options, because the square root of 16 can also be negative. So what we will also get is, and we use this little symbol here, this is or. Okay, you will use this a lot in maths over the next few years. So we get x is the square root of 16, but we also have to remember that we get x equals the negative square root of 16. Okay, so you will get a positive square root and you will also get a negative square root. So the answer could be either one of these. The answer could be the square root of 16, or it could be the negative square root of 16. And the negative square root of 16 is just going to be negative 4. Oops. Okay, so with these you're going to get two answers. All right. Now this isn't always the case. Okay, so this was fine for x squared is 16, or for example, if we have x squared equals 5, then we get x equals the square root of 5, or x equals the negative square root of 5. Okay, this also works. Lovely. Okay, if we have x squared equals 49, x equals the square root of 49, or x equals the negative square root of 49, and that will give us x equals 7, or x equals minus 7. Just one thing quickly, when I did square root of 5, you'll notice I left it as it is. Okay, you should only round it and type it in your calculator if we ask you to, or if it's in a story where it makes sense to do that. Okay, if I don't ask you to, if I just ask you to solve, then we usually want you to leave it in what we call exact form. Okay, and we talked about this a little bit back when we did the square root unit, but I do want you to try and keep things in exact form unless it makes more sense to have it as a decimal. Okay, so these are some examples of where it works nicely. Okay, but there are also situations where it doesn't. So the first example is if I had x squared equals 0. All right, what times itself is equal to 0? Okay, this is a situation of a times b equals 0. So in this case, up here with these other ones, we always got two answers. But if we have x squared equals 0, x must be 0. Okay, and if it's 0, there's nothing else it can be. Okay, so when we have a positive answer, we get two solutions. When we have 0, we get one solution. Now, what if we have x squared equals minus 16? Okay, now we talked about this when we did the square root unit, because x is going to be equal to the square root of minus 16, or x is going to be equal to the negative square root of negative 16. But we said in the square root unit that this has no real solution. Okay, and that's the same for this one. So if you have a negative answer, if C is negative, then we have no real solution. Now I want to talk about what this also means, okay, because this really means nothing on its own. Let's go back and have a look at x squared equals 16. Now what we're actually looking at, I'll write it down here. If we have x squared equals 16. We can look at this as two graphs, okay? So we can instead make this something like this is the same as saying y equals x squared, but writing it backwards. So this would be x squared equals y, okay? And in this case, our graph is x squared, and our y is 16. So what we can do is we can actually graph this, all right? So if we make a set of axes, like this. Okay, we have y equals x squared. Okay, and we know that that looks like this. This is y equals x squared. Okay, so that's what I've written here in green. But I've also said that y is 16, haven't I? I said here that we've said that y is 16. So what we actually have is we have a second line, a horizontal line here. And this line is y equals 16. Okay, so when we solve something like this, when we solve something like x squared equals 16, what we're actually looking at is we're looking at y equals x squared, and we're looking at y equals 16. And if I do this in blue, because that's what we actually wrote, y equals x squared. And we're actually looking at where these two lines meet, okay? So our y equals x squared is that lovely parabola, okay? That one we already looked at how to graph the parabolas, okay? So y equals x squared is this nice parabola. Y equals 16 is a straight line, and we're actually looking at where they meet. And if you look at this point here and we take it down to the x-axis, you guys have already solved this. Okay, this was a sketch, not an exact answer, because you guys already said way back here that the answer was 4 and minus 4. So what we've actually found is that where these two lines meet is, this is x equals minus 4, and this is x equals 4. All right, so that's what we're actually finding when we do these. So for example, if we have x squared equals 5, okay, what we're actually looking at is on our axis, we have a parabola for y equals x squared. And remember, that always goes through 0, 0. So this is y equals x squared. Then we have a line for y equals 5. And y equals 5 is always going to be a horizontal line like this. Y equals, well, I don't know what just happened. Y equals 5. Okay. And we are looking at where these intersect. We're looking at the intersection points. That's what we call these. Where these lines meet is called the intersection. Okay, and what we actually find here is that these two lines meet at negative square root of 5 and square root of 5. That's what we've actually found here. Okay, so this is what we're actually finding when we do this. If we had a parabola that was the other way around, okay, so for example, we have minus x squared equals minus 8. Yeah, that's fine. Let's make it minus 8. All right. What that means that in this case, we have a negative parabola. Okay, negative x squared means it's the same thing, but it's upside down. Okay, so it looks like this. Okay, so this would be y equals negative x squared. Okay, because that's what this side is, y equals negative x squared. And we want to know where it meets the line y equals minus 8. And that's going to be along here somewhere. So this would be y equals minus 8. And we can again find that intersection point, that point where these two lines meet. Okay, and that's what we're doing when we solve them. Okay, so in this case, let's look at that. So we have minus x squared equals minus 8. Our first step here is going to be divide them both by -1. Okay, because we want it to be x squared equals something. So minus x squared divided by -1 just gives us x squared equals 8. Okay, and then we're going to get x equals the square root of 8, or x equals the negative square root of 8. And that's what we have here. So these intersection points are negative root 8 and root 8. That tells us where these two lines meet. Okay, so if we were looking for one of the intersection points, it's got to be one of these two. All right, and this is what we're looking at when we look at x squared equals c. So with x squared equals c, if c is greater than 0, we always get two solutions. So there will always be two answers. There'll be two intersection points, and you can see that in these graphs. Okay, if c is positive, then the line will always cross twice. All right. If c is equal to 0, then we will have one solution. Okay, and I'm going to draw a little sketch in a sec to show you why all of this happens. If c is less than 0, then that's when we had 0 solutions. Okay, and again, this is because on our axes, okay, in the first example, this is y equals x squared in all of them. In our first example, if c is positive, that means it's up here somewhere. Okay, and you can see it meets it twice. In the second example, if c is 0, then our c is going to be this line across here. And you can see it only meets it once. If c is less than 0, you can see that this is our c line down here somewhere. It's below the 0 line for the x-axis. And therefore, there's not going to be any solutions because the lines never meet. Okay, you'll do a lot of this next year. All right, good luck. There are some slightly harder story questions, but these ones are pretty good. Okay, so just have a go at them, see how you go with it.